All right, guys, I'm Old Man Builds, and I'm here with Merkaba Magnetricity, and we're looking at his invention right now. You want to go ahead and explain it? I'll go ahead and put up a video real quick and just show everybody what it looks like.
From the ball without...
There you go. We're good. It's up.
Right. So it's hard to explain where it's really come from. I started looking at sacred geometry back in 2003, 2005, and just something clicked with me that this shape, the Merkaba, the Stella Octangula, can easily be wrapped with wires as a coil form. And just something in my head said this is going to make a generator, and that's where it sort of started. Lots of YouTube diving, and it literally has just come out of what happens. I don't know where it comes from, but it just seems to make sense what I put together, and it works. This is what I find intriguing. But it's basically based on a feedback loop. I use audio amplifiers to spin the ball. And the reason I do that is because before I built the machine, I was talking to an audio technician, and I was asking what the sound was when you put the microphone next to the amplifier, next to the speaker sound. And he said that was the sound of eternity. And again, it just clicked with me, which, you're making a feedback loop. And to me, those three coloured coils that you see there, the large ones that wrap round, make an octahedron. They're connected in series, and they generate a magnetic field, but they're acting as the speaker. And on each of the points, not on this version that you can see on the screen, but on the latest version, it has one on every one of these cross points where the intersections are, which again, the whole shape lends itself to this. So then there's fine wired coils on each of those 6 intersections. That's acting like the microphone, and they're literally just put through an audio amplifier. And as you start the ball spinning, I only switch one channel on, and then allow it to get up to a certain speed. It's a bit like driving a car. It feels like you're changing gears. So then when it gets to a higher speed, I turn the second one on, the third one on, etc. There are some videos that on. And the way I like to think about it is it's the sound of the magnet playing the sound of the magnet spinning that makes it go faster. It's almost like hallelujah. It goes round and round. It can hear itself spinning. It's an audio feedback loop, but with electromagnetism involved, obviously.
So, just real quick, you put a coil where they meet on the corners. Is that what you were saying? So that it starts up the ball?
What you have to do at the current builds is you just get a magnet and give the big ball in the middle, the ball neodymium, the spherical neodymium, a bit of a whip, and that little spin. And it always has to spin. If you look down, it has to spin clockwise. It won't spin anti-clockwise. Whether that's something to do with the wiring, the way I wired it up, I don't know. So once it starts spinning and the amplifier is turned on, it takes a little bit of tuning with the bass and the treble and the volume, and then it just starts spinning. And it doesn't want to stop. If I can get it going faster with lack of friction or hovering the magnet, there's lots of different.
Sorry, give me 1 second. I'm looking for something here. You move your hand. What is that doing? Like when you
when I flick it, yeah. So when I flick it to start it going earlier, there'll be a magnet in my hand, and that's just to interact with the magnet in the middle. So that's not it, is it? But yeah, you can see at this point as well on this early version we're looking at here that I started to put those coils on the points. You can see a green one here on the left, a yellow one to the back, and one above. There is one below, and there should be one on the right.
So it puts out sound like a speaker, is what you're saying, with your audio amplifier.
Yeah, the thicker wires are the speaker wire. Yeah, so they're attached to the output, and the input is all those 6 small coils, but they've all got individual switches to switch them on one at a time, because you can't just switch them on all together. It just makes a horrible sound and won't start spinning. You have to have just one feedback from one of those small coils and then turn it on. And then once it gets to a certain speed, then you can introduce the next coil. And there is a sequence that you find that it's like tuning an engine. You know, I think it's unique to itself at that point. And the new build, which I'm on with, I've not got that up and running again, but I should expect I'm going to hit a lot of the same issues I had there, trying to find out which coil reacted better and move them about until I get the sequence so that I know which order they need to be turned on.
So you literally are putting a symphony in this thing. So one, then the next. It's like a different chord on your guitar or something. Just one, then the next, and then the next, and it just makes a beautiful musical tone. But it's spinning the magnet while it's doing it.
Yeah, and that, you know, there's a couple of videos that I've spoke to you about in the past that I did some experiments for myself, just 3D simulations to see if what was going on. So the only thing I knew how to use simulation-wise was 3D Studio Max, and I put because I had 3 coils, these three speaker coils on those 3 axes. It is identical to the Montauk Delta T antenna. I'll see if I can get a link for Nathan to put in the comments.
Well, can you explain that just a little bit of what he's talking about?
The Montauk experiments, it's what Stranger Things is based on, if that's right, where they did mind control experiments. Is it an Air Force base? It's closed now, but supposed to be closed. But there was people that took place in these experiments, and one guy built a Delta T. What did he say it was called again? Delta T antenna. That was it. I couldn't believe it when I found that information out, and I was already building this thing. And they start talking about really exotic stuff, like time travel, and yeah, it's interesting stuff. But,
it's almost like an open air resonance chamber that you have sitting right here in front of you. Because as you put in sound from different direction, it creates different things. So it's almost like if you put a core around the whole thing of it, man, it would change the whole thing coming out.
Yeah. There's the idea that you can introduce frequencies onto the signals. I've attempted something similar, but every time I did it, I went off and read about it. You can't put a DC signal onto your inputs, otherwise it just causes something in my amplifier to shut down. I'm always frightened of blowing them up because they're hard to come by, these good ones. But I would like to, reduce the size of it. But the one that I built previously out of brass works. I don't know if you've got a picture. I sent you or the video I sent you earlier.
I could show it.
Build. Yeah.
So this one right here.
Yeah, so there's the old one that you see in videos of currently, and this is the new build on the left. I bought the two printer there. I bought a Creality K1 Max, and it's been 10 or 15 years since I owned a printer or bought a printer, and the technology has done fantastic. They said, oh, that was it. Yeah, sorry, exotic propulsion thing. The operator was sitting in a chair. Didn't they put a big one there as well?
You got a bigger one on there?
No, I didn't. But exotic propulsion's distracting me with his talk about the Montauk there in the chat. Yeah, so the one on the left is the Mark II, if you like. I'm currently replacing a lot of the steel screws I've used, even though they're stainless. I want to replace them all with brass because the framework's that extruded 2020 aluminium. And the way I built it, I've designed it so that I've got all these parts, and anybody, if they want to build it, could build one of these things and start to experiment with it. But it's far superior to me. I was always very frustrated with the fact that even though I've got these skills in an old 3D printer, I never built anything other than the little blue thing you saw in the middle to put the ball in properly. And this chamber is all designed to take the Mercury. That's where I'm going with it. It was interesting to hear Exotic Propulsion talking on the last chat that he had, when he was on about something that I'd just this last couple of months had come across myself, that there used to be Mercury buoys on the sea that were self-illuminating, and all these were Tauruses filled with Mercury in a vacuum, and the rocking of the waves would light them on the sea so the ships could see. And this is going back to 1800, this diagram that I showed. I think I sent it to you, didn't I, Nathan?
Yeah, let me take a look real quick. There's a lot on here.
Yeah.
Yeah, let me look.
There you go. So that
writing. Sorry. Not that.
Like a page from a book, black and white page from a book. Keep going. Yeah, look. There was only one there. Why is there only one?
Oh, sorry. This one. Is that what you're talking about?
No.
This one?
Yeah, it should be with that one. Is there only one there?
Yeah, I'm not seeing it right now. It pulls up all the pictures that are sent to my Facebook. Just send it in and I'll pull it up real quick.
So yeah, this is the image that I saw, and it just said self-illuminated boy, and that sent me down the rabbit hole. And again, it was one of those things about this machine, not Exotic Propulsion, but the same sort of experiences when you're doing your research. In your head, you always knew that you were right, and then you start finding things like this that tell you that you were all along. And one of the videos I sent you was me holding the ball back in 2013. Since I've been building prototypes for the core, that was the bottom of our chat. And I've always put a Taurus in. That one just come?
That one just came up, yeah.
Yeah, that one there was back in 2013 when I had my really old printer, and I'd put a Taurus in then to take the Mercury. That's what I always intended to do. One of my biggest failures so far, not a failure for learning, was that I always found that I had a little toy when I used to spin the ball. I know I had you guys going, oh, it's crazy, it's open one end. Well, I used to use a little stacking cup from the children's stacking toys, and it was a cylinder. And it always used to spin like mad and spin for about 5 minutes with the inertia afterwards. From the speed that he was attaining. And I don't know why, because I was so pig-headed about it. I've designed everything with a sphere to take the spherical magnet, but that is completely wrong. A cylinder is the best shape if you're not levitating the magnet to put it in for minimum surface area contact friction. So that's
I saw that and I don't remember if it's on here or not, but it looks just like a test tube cylinder. And in the inside, it looks like DNA as it's swirling. Is that in this one? Is that what you're talking about?
Well, the one where I'm spinning.
No. It was just a photograph. It might be in something else I was looking at.
Yeah, no, I don't think that was me.
Sorry, man. I've been looking at a whole bunch of information lately, and it's just been like sitting in my brain. You know what I mean? Festering. I'm trying to figure it all out.
Yeah. Well, it's a rabbit hole, isn't it?
Oh, it is. It definitely is.
So where I'm going to try and take it, I think one of the guys in the last live stream, one of the last live streams did was mentioning whether or not the Mercury will be generated pressure inside the Taurus that I've currently got it in. And yes, it will be, and it will always will, no matter what I put. I'd like to think that would create enough pressure for maybe is it barometric light, exotic propulsion we're talking about? Is that the phenomenon we're talking about when the Mercury glows? Barometer light it's called.
Give me 1 second. Just interrupt you. Everybody's saying your volume's low. Is there any way you can turn that up?
My volume.
Yes.
If I dump the headphones, turn Bluetooth off. I don't want to lose you. If I do, I'll hop straight back. I'll take the headphones off. 1 second. I think you're still there. Okay. Turn these off. Just need to use the microphone.
Are you still there?
Oh, no. Yeah, now you're super loud. Okay,
All
go
right.
ahead.
So there must be a microphone in my son's earphones.
Oh.
So yeah, it is generating pressure, and where I'm going to go with it currently is I'm going to cast and pot it once I've wound the coils on the on the Mercury core with the Taurus. I don't want to get it out and drop it, but you've seen this in the video. This was in the screenshot. So what I intend to do is, once these are wrapped, is to pot it, and then if I do need to get the Mercury out, I'll have to drill it out. They're only cheap, these Tauruses, to get hold of, but once it's potted in epoxy resin, that should hold it. But that motor, did you play that already in one of your other videos?
I'm going to play it right now. Hey, I had a question right before I do.
Yeah.
The epoxy resins, does the mercury interact with it and eat it?
I don't know, but it's not going to touch the epoxy resin directly. It's already in a plastic tube, and plastic's safe to store mercury in. There are better things. Iron is one of them, but I can't use iron because of the magnetic core. Yeah, so it won't be touching the epoxy resin. I intend to cast a plastic Taurus inside with all the coils and to house it in case it does make any pressure.
Gotcha. Let's take a look real quick. I'm going to put up your first mercury one, and I'll pull your second one.
Okay. Loud is. So yeah, this is the spherical magnet spinning in a spherical housing, and sometimes you can hear it struggle, and I don't think I would have got as much, it wouldn't slow down as much, because obviously there's a diamagnetic thing going up, because Mercury is diamagnetic. So it's like when you hold copper near magnetic braking, they call it, don't they, when they use copper to slow, I don't know, roller coasters and things like that. So the Mercury does slow the magnet to some degree. But this one is fantastic because you can see a double vortex. When I had it held vertically, the Taurus, you could see a vortex developing at each end of where the Mercury terminated.
So let's take a look at that real quick.
There, that one. Yeah. And I should have another go and see if I can get in closer with the camera, because I've got a better camera now.
You can see it. If you look at the right one, it's starting to indent into it. And the left one.
Yeah, he's literally creating, well, he's trying to join up, I guess, is it? If they're both creating a vortex from...
It's trying to create a hole in between it.
Yeah. Yeah.
That's neat.
That was just one of those things that you just observe while you're doing these things, because I'm not a scientist. I'm just a practical person, and this stuff interests me, and it has done for a long time now.
I think it interests all of us, man. We're all into this stuff. Let me pull up the other one real quick.
The test bed.
Yeah. So it's this one here.
Yeah, so I'll let you play it and then I'll explain it. So that is a radio control drone motor.
Okay, hang on. I'll just remove this. I just want to have you show it a little better. So
yeah, what I've done here, it's a test platform, if you like, because I'm still rebuilding Mark II, let's call it. There's a couple of things I need to know. I'd seen a guy, Matt, from Elevate Cultivate, I think his channel's called. And he got a tri-field meter, and he shook Mercury in front of it. And again, it said to me, I was right all along, because what I'd seen that got me on the Mercury thing was the Faraday motor. And all of these things that we're looking at here, the basics of it, copper coils and magnets, Peltier devices, LEDs, Mercury. What's the other one? I've got a list. I sent you a picture, actually, with the 5 equations, as I call them, on. Can sound cause eddy currents? I don't know, Sean.
That's an interesting question.
Yeah.
I don't know that it does, but it may. Let's look at the so on this one, I'm going to mute it here.
So
You're
what I'm trying to
forcing
do,
the magnet.
Yeah, so there's a magnet in the middle there. Normally my ball obviously is magnetized top and bottom, or left and right, whichever way it falls in the chamber. And whatever those fields are doing to it is how it'll lay. So what I've done here is I've got a diametrically magnetized disc magnet with a hole in the middle, and where the propeller would go on the RC motor, I've just mounted it on there. And then I've worked out my heights and distances and built this 3D container to sit the Mercury in there with the torus. And I want to take some readings. The readings I want to take are, I want to do an empty torus that's wrapped with coils and just read the electromagnetic energy coming from those as a baseline, and then duplicate the windings on the Mercury torus and take those readings and see if there's a difference in the electricity, and see if it can be taken out of the Mercury just by using the coils around it. I don't know if that can be done, because I'd envisage that you should actually stick a cathode and an anode in it to extract the energy. The magnet's causing spinning. The magnet spinning, Sean, is causing the Mercury to flow.
Let's put this one up. Okay.
Oh no, sound and light. I don't know what that means. So yeah, that's where this platform's at the minute. This is just a test platform, because I wanted to replicate what the ball magnet does in the core of the Merkaba generator machine, and this is just a test platform at the moment.
Okay, so we saw the we saw the coils in the first experiment. How do they translate to this experiment? Because you were putting the sound throughout.
Yes. So what you saw me in that earlier video, using a torus near the core of my machine, and that's using a ball magnet, and obviously that's causing the Mercury to spin. So we know that happens. But where my build's at the moment, I need to know some things before I finalize a design, or I say finalize, it never finalized. Before I build the actual core, I need to know some things about what the Mercury is doing, how we're going to get the electricity out, the diameter of the torus and things like that. I'm filling my head up now. There's lots of things to try and look at. Where do you draw what?
Sorry, which one?
Sorry, I'm just.
It's all right. Go ahead. I'll put it up so everybody can see it.
I wonder if you could get gyroscopic stabilization if the Mercury or the plasma could be spun fast enough. Definitely going to be a force that we're going to be reckoning with, isn't it? You mean like the bicycle wheel thing where you spin it and hold it? Is that what it means?
I think so.
Yeah. I should imagine you will get some kind of gyroscopic forces at play. But it's heavy stuff. And as soon as I turn this RC motor off on the test bed, the Mercury doesn't keep going, not like the magnet does.
So the Mercury just stops?
It'll just stop. Yeah, it's heavy stuff, isn't it?
Yeah. So
very heavy stuff.
Tell me about the windings here. You have spaces for the windings in here. What are they going to do in this particular situation?
Okay, this is where it sounds a little bit crazy. So say what you like in the comments. My original idea to try and get the energy out was to wrap the whole torus with copper windings all the way round. But I've always known, could you, just one second, Just 1 second. I'll be straight
Yeah,
back.
go ahead. Sorry about that, guys. Yeah. Let's go ahead and read a couple of comments. Crystal lattice that could be thought as tangential structures. That's interesting. All right, y'all good?
Yeah. What was I saying?
We were talking
Right.
about the windings, and instead of going full coil around.
So I was going to wrap the whole coil with copper windings, but I've known since the beginning that there's 5 things I want to use, and the LEDs, turning LEDs into like a solar panel is one of the ways of pulling. It's a reversible equation. If you give an LED electricity, it gives you light. If you give it light, it gives you electricity. And obviously, the Mercury in a vacuum with a barometer light or whatever exotic propulsion called it, it's going to glow, and that wants to be harvested. All the energy from the machine is, in my mind, is what you need to aim to harvest it all, whether it's heat, sound, light, and the spinning of the Mercury. And but it's UVC light. So I suddenly realized when I started wrapping this coil with this copper wire that if I cover it in copper wire, I'm not going to see the glow. So I separated it. I put those separations in and made coil forms where I can wrap the wire. That's what those white sections are that split it up, and it ends up looking like Iron Man's heart, which is crazy, but that's what it's practical because it's going to let the light out. So you've got somewhere to put UVC LEDs, because that's where I'm going with it to test. You can take a normal LED and hold it in the sunlight and test that you're getting a voltage, and you'll get a voltage. But you can't do that with UVC light that the Mercury will give off. It has to be a UVC LED, which makes sense. It's doped with a certain.
There is an unfortunate downside to UVC claimed LED technology. So it's really awesome to have you on here. I actually have some of your videos, Merkaba, Magnetricity. I have some of yours saved on my anti-gravity playlist, have had for years. And it's super awesome to actually see the guy behind the channel because I love the work. And it's brought up a lot of conversations amongst our private research groups as well, because, a lot of us, we played around with Mercury and rotating systems. But as far as demonstrations go, you have some of the best. So it's a pleasure to meet you.
Thank you.
What I've got here is a little vial of mercury. There's some contaminants floating on the surface, which should help with visibility. I've got a Dremel tool here that has a 4-pole in-runner BLDC rotor. So north, south, and that's going to induce a rotating field, very much like the 2-pole or dipole magnet ball. And then what we're looking at here is a homemade magnetometer probe that's hooked up to the scope. So unfortunately, there's a little bit of variation. I'll just zoom in on that to show the problem that it has. But you can see that there's a bit of a spiked waveform here. And that's because the internal voltage controller in here is generating some noise. So that's not part of the signal. But what I will show you is if I turn this rotor on, sorry for the noise.
No problem.
So it's running at a relatively low RPM. We can see that we're generating a sinusoidal pickup by our Hall effect sensor inside this probe that's located right here. And if I increase the RPM, so what I'll do now is take this small cylinder. I'll tilt this down so that we can see it. All right, let's see if we can get any kind of camera view that works for this. That might be more tricky than I thought. See, can we, I'm not sure how well that is focusing. Guess I'll hold this light up next to it, perhaps. And maybe we'll be able to see some rotation. Tell you what, give me a second. I'm going to move my camera back a little bit.
Cool.
There we go. That should work much better. And plug that back in. There we go.
Yeah.
So the signal starting to tilt up. So now the surface is rotating. It's not moving very fast. The electrostatic induction and the magnetohydrodynamic induction is not particularly strong in this case, but there is a bow in the center.
Yeah.
Unfortunately, this vessel was really very poor choice, being that it's darkened glass. But there is another thing that I put together a while ago. Unfortunately, during daylight conditions, I can't really show it very well. But this is a 2-inch diameter.
Is this the one you pulled about?
Go ahead.
Is this the one you pulled a vacuum on?
Yeah, this is the one I pulled a vacuum on. And so inside there you can see the puddle of mercury. And so all I did is swirl it around like this, about this speed, and in a fully darkened room, which won't be possible with the low CCD sensitivity or ISO on my iPhone camera. But just spinning it around at this RPM, you're generating plenty of light. You can't quite see where you're going, but I did another version of this where I put in a bunch of phosphors from a fluorescent tube and just let them sort of float on the surface of the mercury. Well, they would get stuck. They would want to float and then get pushed against the wall. And as the mercury flowed across the phosphorus, it would convert the UVC light, as you mentioned, into visible light, which had quite a plethora of colors as the phosphorus kind of got isolated from each other. So we had reds, blues, and greens that were all clearly identifiable. And such a low RPM. I mean,
yeah, very low.
The RPM of this rotation here of the oscillation of my hand, and it's really not moving that fast across the surface. So you can imagine, just if this was a very large diameter tube, say like a 2-foot wide diameter by 1-inch cross section tube, and it's just tilting back and forth, that buoy, it could reach the same kind of velocities that I'm achieving there by hand and easily generate enough light to be seen in the extreme darkness of the open ocean at night.
Yeah. Had you come across that diagram that Nathan showed us earlier?
So there's a lot of really interesting stuff too with Mercury. And one of the stories that I heard, and consider this speculation because I've never been able to verify it, but a gentleman that I had a chance to speak with over the phone, he had a very curious experiment. And what he did is he took a small pool of mercury, not much larger than what's inside this glass bulb, and wasn't under vacuum or anything extreme like that. And he had used a pulse metal detector, which is, there's two types of metal detectors. So you have your first type, which most people know of. It uses a sinusoidal waveform, and it looks for an active feedback. And the second type generates a quick pulse, and it works more like sonar. An electromagnetic pulse travels down from the coil into the surface, into the ground, and then whatever comes back, that pulse is already over by the time the pulse is received. So it generates a very high electromagnetic field in terms of its amps per meter. And so when he induced that field onto a pool of mercury, he had noticed that a variety of colors were produced under normal operating atmospheric conditions. And he got quite the plethora of colorful aurora-like glows off the surface of that mercury. And so it seems that electromagnetically, if you excite the mercury with a high enough power pulse, there's yet another level to these effects that we haven't even seen yet. And I believe this is partially due to, if we consider like the surface of the mercury and the surface of the glass as having some sort of triboelectric stiction interaction, and then looked at what he had done in his system, he was effectively inducing the same types of surface potentials that would normally happen inside the glass. Only he was doing it wirelessly with this pulse metal detector. So there could be a lot more to the power of mercury I'll switch off my cam for a second, and I'll pull up a PDF and show you guys real quick Thomas Townsend Brown's design of a Mercury power generator.
I did not know he did one.
That's why I love these things, man. You kind of learn everything from everyone. Give you some new ideas to try in the future. Seems like T.T. Brown was into everything.
Brown was certainly a genius of his time. There's no doubt about that. And he did get into quite a few things. The biggest catch with what people misunderstand about Thomas Townsend Brown is they've got this idea, and I don't know why it was so popularized, perhaps between Jean-Louis Naudin and a few others. People got the idea that Brown had stopped at lifters. Now, I imagine everybody that watches your channel, Old Man Builds, has good familiarity with what a lifter is. It's this little triangular form airfoil, very lightweight, uses electrodynamic potentials in order to produce a lifting force on the hull. Now, I've studied this quite in depth, and what I found is that the ionic wind produced can be almost completely eliminated, meaning that you basically have no airflow in order to produce lift. It turns out that what really happens is at the top of the ionization wire, instead of just having ions flow down from the ionization wire towards the collection plate and generating an airflow, which is equivalent to a thrust, what really happens is the ions also fly upwards away from the collection plate. And they create a huge cloud of charge above the collection plate. Well, now you've got a massive amount of free-floating ions, free unbound charges that are now flying around the atmosphere, and the amount of volume that they take up in terms of the atmospheric gas density is, or can be, greater than the amount of weight for the craft hull, meaning that instead of the craft being pushed by thrust upwards in order to create a lifting force, what it actually is doing is being electrostatically attracted like a capacitor plate towards the area of opposite charge density. And that's being done due to volumetric displacement of the entire atmosphere. So the craft may travel upwards at 20 miles an hour, while the atmosphere that's surrounding it, because it has several hundred times the total volume of the craft surface area, it may only be traveling down at maybe a couple inches per minute.
So funny, man. I can't get people to understand that simple fact. Charging things changes everything. And the lifter isn't working the way you think it is.
Not at all. No, I mean we've gotten lifter technology to the point where it's 4-to-1 ratio, no problem. And if I include power supply, it's still 1.5 times 1.5 to 1 ratio in terms of power to lift. And the reason why I haven't released this is because I'm friends with Ethan Krause. He's the first guy with Electron Air LLC to ever release a full VTOL type of device that can use nothing but electrostatic charges and ionic flow in order to produce a self-lifting craft. So it's all self-powered. It's got a battery on board, and Ethan Krause has a patent on it. So long before MIT and their famous ion plane had ever taken flight, Ethan Krause already had a VTOL craft that was fully operational and radio controlled. So MIT was second to the game, but of course they got all the news press because big organizations, that's how academia works. They don't care about the little guy. But nevertheless, Ethan did it, and he's been doing it for over 20 years.
And people wonder why I use charge instead of magnetism in my gravity flyer. It's a whole different way of looking at it.
It absolutely is. So let me go ahead and turn this on. So this is going to be a little bit crude. I do apologize. I'm on my cell phone and my document is on my computer. But this is Thomas Townsend Brown's Mercury power generator. And what he's got basically going on here, I'll just show you here. Here his signature is at the bottom as the inventor. And it was signed off by 2 witnesses that seen the machine operate. The name's here. And this is February 24th, 1933. And so what we have here is almost identical to a Vimana engine in the classic Vimanika Shastra documents. And we have a round boiling flask. In Brown's case, it was Pyrex. He has a constricting nozzle here, part B. And part B here, the mercury vapor that flows up from the surface of this heated flask, which was heated with a flame in his case, but now could be heated easily with electric heating element. The mercury flows up through this nozzle. It accelerates because the nozzle is thinner than the total volume of the surface area. And it goes between these two electrically charged plates. So we can see we have these terminals here connected to these metallic plates on one side and the other. If we look at it from top down, we're looking at the metallic plates that we just seen there on the top and bottom. But on the sides here, there are two massive solenoid coils. And we can see, I'm not going to rotate my camera because it'll just flip anyways, but these two solenoid coils are orthogonal to the electric field plates. So through the principles of MHD, as the mercury gas accelerates up this nozzle here and starts to flow towards the top and back into the condenser region, the differential in ionization between these individual mercury ions that are being boiled off of the surface of this liquid pool here, well, they're diverted away by the magnetic field. Now, of course, today we would use permanent magnets for this application. We wouldn't use field coils as he's showing here because field coils are going to consume power. But this could be completely done with permanent magnets, and then the only power input required would be whatever the differential is between heating the mercury and then condensing it back in this condenser. So you're going to, the mercury ions follow the right-hand rule, and this was able to generate a potential between these two plates, and he was able to extract power off of this. And it's a very interesting means and method of creating a device that can extract power from flowing mercury vapor. Later on, let me see if it's in this document. Yeah, here. So he actually does build where there's a full condenser on the top. He's got this nice large water-cooled condenser, and he's optimized the design of the final drawing, and this is what it looks like. The shape of the dewar is changed. There's less mercury inside of the system. There's a much thinner restriction nozzle, and so the velocity is higher. And then the return tube, after it goes into the condenser here, velocity is extracted, puts it back into a liquid state, and it drips down through this return flow back into the mercury boiler down here at the bottom. So it's not a particularly complicated device. And he shows some of the switching for how you can extract. He draws this up, and in the text, which I'm not going to get into too much, he describes this as a preclusion to a patent application, but it never got to the point of actually being patented, never even got to the application stage to do with mercury that's not being done. And of course, we know that pretty much across the board, our governments have done their very, very best to take mercury out of the hands of the civilian.
Yeah.
There are good reasons for that. I'm not gonna say it's a conspiracy or anything like that, but there are good reasons. You know, mercury is technically, toxic to the environment, toxic to human life, especially the vapors. In its aqueous form, it won't actually absorb into human skin unless, of course, you have sweat on your skin, which is pretty much 24/7 for humans. We always have some kind of salt on our skin. So mercury will form a salt, and when it does, it can be absorbed into the skin. Otherwise, if your hands are completely dry and completely free of oils and completely free of salts, you could roll around a pool of mercury in your hand and it wouldn't pose any particular danger. This is an old classroom physics demonstration that used to be done, but now is, of course, completely forbidden because, well, people don't understand the dangers or the lack thereof involving mercury experiments. Although I would certainly say for anybody trying mercury experiments at home, definitely don't unless you have a proper enclosure, a vent hood, and at least some catch tray in case you have a breakdown of your enclosure. So you want to be able to catch that spilling mercury, obviously. So don't try these experiments unless you really, really know what you're doing.
Yeah.
It reminded me, the diagrams you've just showed us, you can't help but think of Vimanas when they're heating the mercury from the bottom. That was in the text, wasn't it?
Absolutely. The Vimanaka Shastra states that the mercury boiler must be built extremely rigid, and strong. So they would make their mercury boilers out of iron, which is actually an ideal element because mercury will amalgam somewhat with iron, but because of the carbon content, the carbon will actually form sort of an insulating layer where mercury will not amalgam with carbon whatsoever. And so the carbon would create a barrier where as the mercury was flowing over the surface or being separated, the iron vessel would stand up pretty well to the heat and to the pressure. Of course, it wasn't it wasn't a permanent forever solution. It's not like it was made of molybdenum, one of the two metals that can withstand and not amalgam with mercury under normal conditions. But iron will still technically work in a pinch. And of course, today we would use borosilicate or something else like that, or we would line the inside of the vessel with ceramic. Basically anything that doesn't amalgam with mercury.
Did you see, I put a little video just showing a toy that you can buy. I call it a toy, it's a scientific demonstration toy, a Leidenfrost now.
Did you put it up on the Facebook?
Yeah, I just sent you a link to it. I don't know if you can do that.
Yeah, give me just 1 second. I'll get out of this and I will pop over there. Okay, I have an older gentleman on here who's doing something. I'll share the screen.
Oh, that's an interesting one. While you're pulling it up, I'm just looking at a document here I have from 2017 called Deformed Space-Time Transformations in Mercury. And quite the list of authors on this paper. So I should really send this to especially you, Merkaba Magnetricity, because I think that you would really get a kick out of these. I've got about 12 documents here in this folder, and all of them have to do with mercury involving power extraction or other anomalous types of electromotive effects.
Yeah. Sounds good. But that video that it was just putting up then in the Leidenfrost demonstration toy, when you heat the metal, and I'm assuming you could make one of these out of steel if you had the right tooling, and put mercury there instead of the water, and it would still do the spin with the heat.
Well, you don't really get that with mercury. I've tested that, ironically enough, just to see if there would be other compounds that might produce it. But the Leidenfrost effect and the self-rotating assembly happens because you have a layer of steam. And the steam doesn't expand evenly because of the surface being notched and asymmetrical. So when the steam expands, it's forced more out one side than the other, and that applies a rotational force or forward momentum from the point of the steam particles in general to the rest of the liquid water that's sitting on the surface. Well, mercury, unless you're running it at a high enough temperature where you're actually evaporating the mercury liquid into a vapor, which is something that you certainly wouldn't want to do, at least not intentionally, unless you're going to vent it proper. You could get the same kind of effect, but you have to reach the boiling point of the liquid. And I wouldn't recommend that we reach the boiling point of mercury in atmospheric conditions.
No, I would. I'm trying to relate it to the Vimana text in as much as they talk about that it creates a whirlwind, and the only thing that I've ever seen that would start it spinning would be something like this. If it was a steel chamber, steel takes a lot of temperature, doesn't it? Is it 2,000 degrees, something like that, to melt it? So it could take a lot of temperature way above the boiling point of mercury.
Yeah, but so can ceramic too.
So maybe
ceramic
you could in a
glass are really ideal solutions. As I mentioned earlier, borosilicate is not going to have too much of a problem as long as it's evenly heated enough and the vessel enclosure is thin enough where you're not dealing with thermal shear factors. But yeah, we have better materials today than what were available in Brown's time.
Oh, definitely.
Yes.
CCTO, for example. I mean, Brown was really, really excited when he had discovered a dielectric that had a K factor of 20,000, which in that time was just absolutely insane. 20,000 K, totally nuts. Today, CCTO, which is one of our best available dielectrics, has a K factor when properly compressed of over 200,000. So you can imagine what he might have done with that. But you know what people don't talk about is Brown's gravitational isotopes. The difference that he discovered between various isotopes of common elements. Now, if we look at the nuclear spin chart, and I don't have one conveniently to pull up, unfortunately, but the naturally abundant nuclear spin isotopes in all common elements had been measured for what they are on Earth, and you can actually isolate out something with an extra neutron versus something without. And it turns out that that extra neutron, or the lack of a neutron, changes the way that it responds gravitationally versus inertial. So according to Einstein's equivalence principle, there is no difference between inertial and gravitational mass. They should always be the same, and that's considered in mainstream physics to be a gold standard, never violated, never disproven. At least that's what we're told. Well, there are quite a number of experiments, especially amongst the French community, that are done properly and with third-party validations that demonstrate a clear violation between the equivalence of inertial and gravitational mass. Why they're not being talked about in the mainstream, I've got no idea. I suppose it might threaten the tenure of some long-standing professors, but regardless of the reasons, we know that there is a difference. And we can utilize it. Go ahead.
Suppressed physics, isn't it?
It absolutely is.
100% suppressed.
You've got relativists that are absolutely hardcore on GR and ignore SR, ignore QED, ignore a variety of other theories because they're just hardcore on this idea. They want a physical universe. They want something that's made of particles and matter and a vacuum that's made of nothing because it makes the math easy. And if what you do is primarily mathematical physics, where you don't perform any experiments and you never have to actually worry about whether your idea will fit on a lab bench or be possible to produce, then all that is very nice and good. But if you want to build something physical, if you want to make an actual device that works and that performs, you have to get rid of some of the mathematics because they just don't work in the lab. And as in the famous words of Richard Feynman, it doesn't matter how beautiful your equations are. If it disagrees with experiment, it's wrong. And that's really where we've come to in terms of this research is we know that the physics we have today, it's incapable of explaining the phenomena that we're observing in our garage experiments and our bedroom experiments. And so we know that we need to modify the physics or modify at least some variables within that physics set. And that what we have currently offered to us is incomplete. So though GR is not wrong, just as Newtonian gravitation is not wrong, well, Newtonian gravitation was replaced with a more accurate model that was called relativity. Relativity stepped through special relativity into general relativity after just being relativity. And now what we have is a new model, but it's still incomplete. It's just a partial explanation. So it's not that it's wrong, it's just incomplete. And if physicists can today get over the idea that they're working with something that has plenty of holes in it and not stick so hard to the idea that it must be true, otherwise the math doesn't work out right, then we can get rid of the gauging problem. The regauging factor of the vacuum refractive index is not instantaneous. Today's mathematics consider that if you create an electric potential in free space, that the entirety of all the universe instantaneously regauges to compensate for that electric potential so that there is no leftover electromotive force or no free momentum. And it doesn't account for longitudinal modes or Hertz potentials at all in our current mathematics. So we need to reconsider what we're looking at when we look at systems that are operating in a nonlinear regime or anything that is parametric in nature, meaning that if you change one factor, another factor changes by a lot more.
Hey, I got a question. What were we doing in this experiment here?
That was me trying to think about whether or not you could magnetize a steel ball enough for it to become the magnet in this machine equation, if you like. So rather than have a neodymium in the center, maybe a steel ball, because it shouldn't be affected as exotic propulsion just said. There are carbons in certain steels and they can be affected, but what I was trying to do was stabilize it, and what you find is it'll pull to the middle of these ring magnets because it's become magnetized, but it won't pull down because I guess of the density of the mercury. And it was just an idea I had, and I just made a video of it trying to stabilize it, see if it will sit in the middle, because ultimately I think I said to you in a conversation, Nathan, I'd love to get my hands on some liquid nitrogen and some superconducting pucks and see if I can't get my magnet just a touch hovering would be enough. Just, it doesn't have to be, you know, huge gaps. It just needs to be enough in the air to stop the friction. You saw how fast it goes in some of the experiments you played on your live stream last time. I believe it can go a lot faster. A lot faster.
There's actually an easy solution to that. You don't have to have liquid nitrogen. You could use dry ice. And because dry ice goes straight from a solid to a gas in a form called sublimation, you'll end up with a vapor barrier at the surface of the steel ball that floats on a layer of CO2 as it's worked in its groove into the dry ice. And so you could effectively achieve the same kind of virtually zero friction environment. Of course, there is still friction because you're working with atmospheric pressure, CO2 gas at 15 psi. But still, it's one way that you can get the RPMs up to a...
You could use a magnetic bearing, can't you?
You could. You could use also a graphite air bearing, which would allow extraordinarily high RPMs.
I built one. I haven't got it to hand. Yeah. It's the one I got a guy to use a rotary saw and put some grooves in a ball bearing that was the same size as the magnet, and I literally ground it down, and I've printed out a housing for it, and I've got air pipe into it. I've just never tried it with the magnet in the middle of the machine, but yeah, I think it would really help.
So you're doing floating on air? Is that what you're saying? On the inside,
that would be the idea. Yes, yeah. Air bearings are fantastic things. Again, that was just a couple of years ago. I looked at that. I think I've got a spare piece of graphite knocking around as well somewhere. I'll have to dig them out and I'll send you some pictures.
Huh. That's amazing.
But yeah, the machine. What I want it to do, like I said earlier, is harvest all the energy that you can create, whether it's a byproduct or you're deliberately doing it. So going back to the mercury, there's the light. I'd love to be able to harvest that, and the electromagnetic energy that's been created by the magnetic ball spinning anyway. You've got the heat generated in the mercury due to the diamagnetic, I don't know what you call it. What would you call it? Exotic propulsion.
And the eddy current induction.
Yeah. That happens, doesn't it? And the mercury gets warm after a while of playing. You know, so you got heat. You got heat coming.
What's surprising about your video is you've got these coils pretty damn far away, and being that they're so wide and the magnet sphere is so small, normally when somebody designs a motoring system that can reach relatively high RPMs with a good coupling coefficient, the coils are extremely close to the rotor.
Yeah.
In your case, they're many times farther away than would be idealized, and the fact that you're even getting good coupling with your delta T type coil system is pretty impressive.
It like I say, I don't know what, other than the fact that I was looking at old time radios, and I had a book on coil forms, and when I started looking at this shape, this lends itself. The coils don't fall off. And then you've got your X, Y, and Z axes, which is fantastic, you know, for balance. Have you got that video, Nathan, where I I released the particles? I didn't finish telling you the story. I released particles in a 3D environment, and I set up vortex manipulators inside the 3D environment. And when I release the particles, they form the shape of the Merkaba in the middle, and I don't understand that. And all I've done is use the vortex manipulators, or whatever you call them, space warps, on the X, Y, and Z axes, and the particles. I don't know what we're seeing.
Sorry, give me 1 second. I'm pulling it up. Right here. This one?
Yeah. So when the particles are released, I think there's the black and white version of a video. Is there? Did I send it? Tell me I sent it. Yeah, it's just below the Roman swastika. There. Keep going. There. No, next one. To your left. There. So when I release the particles, and the Merkaba is just there for reference. That's all it's doing. There is actually an image of the setup that I sent him. But can you see how the particles are forming the shape of the Merkaba? And
yeah,
all that is,
that's essentially field compression.
yeah, but that's just using an X, Y, and a Z. But they're counter rotating, so there's 6 fields there. So there's 2 on every axis, but they're
absolutely, yeah.
But they're opposing.
And that's your system.
Yeah,
I gotta say it's amazing work. I just got linked to you and started looking at your work. I think that's the way your brain works and how that came together. That's really awesome.
That'll be the Asperger's. So yeah, there's another one that I sent Nathan. Let me see if I can see it. Have I sent it as a video? I hope I did.
Hold on.
Yeah, it's about 4 away from that one, Nathan, where I found whenever I see that shape there, that Roman swastika with the particles, what I did in Fractal Draw Pro.
Okay.
Go left. Keep going left.
This one?
No, left. No, keep going. Keep going. We're getting there. There's a video of it there. So what that is it's an old program, Fractal Draw Pro. And I saw that, and you see the swastika and this star quite a lot. And it seems to suggest pictorially spin. But when I drew 3 triangles that you can see there, the black lines where the 3s are, it forms a swastika. Now, how did the Romans know 2,000 years ago that there's some correlation? Because I'm assuming they did. Otherwise, why would they have done this shape? But it took 2,000 years for me to have a piece of software to draw out these triangles to create this fractal, whatever's going on with Fractal Draw Pro. And it generates a swastika in the middle, a spin, a symbol for spin.
Well, they could have simply looked at the flow of water over the surface and in a closed system easily derive this. Actually, Action Labs, I'm sure you've seen Action Labs videos, and he's got a very simple one where he takes a glass slide, a microscope glass slide, and coats it with candle carbon. So he places it over the top of a burning candle, lets the carbon deposits or they collect on the surface, and then he scribes into the surface a swastika type of shape, more curved to the edges instead of being sharp right angles like this. But anyways, the water droplet, it hits it in exactly the center of this structure. It expands out towards the edges, and then as it contracts, the asymmetry of the curvature causes the entire droplet to start rotating. And so this is one way that they could have easily observed this, is if they create any kind of structure, any kind of obstruction, that if you simply push water in and out, the net result will be a rotation in the direction of the spin orientation based on how fast the water flows out from the center point and expands or flattens out versus how fast it comes back in.
Yeah. But we'll never know. We weren't there.
Oh, we'll know. We'll absolutely know. I would never say we'll never know, because we're doing these kinds of experiments now and we're actually getting results. So we will know for sure.
I have a bit of a different take on it, but Yeah, I think that they knew a lot more than we're aware of, and I think parts of our history have been written for us to the point where we've lost a lot of knowledge when it comes to this type of technology. I think it's going to take a lot of, like Jeremiah says, a lot of hard experimentation and you know, who knows, maybe a few people getting zapped here and there, carefully, of course. But you know, I think that it's going to take, you know, garage pokers and backyard dwellers in order to do a ton of experiments in order to find what we need. And it's also going to take scientific experimentation for confirming all this and writing the theory on it. But again, it's time. It all comes down to time, right?
That's right. If you're going to get shocked responsibly.
Yeah.
Yeah, as Nathan says, fry it and find out.
That's right.
Yeah,
Try it and find out. We got to find the limit of it.
What a great quote.
I do it all the time. It's so sad. I always have a broken part somewhere.
I imagine that at this point, like most of us, you have a giant pile of dead MOSFETs and transistors.
Oh, yes.
Yeah.
And you look at the cost of that, and you don't really want to think about it because you know those things are expensive and they're good components. And oh, mercy.
Yeah, don't do the math on that. Then it's no longer a hobby. It's scary.
I got like tubs of stuff that I put away in case I need an extra part out of something I broke.
Boxes, I understand. I have boxes. Yeah.
I used to go around in my Land Rover to industrial estates when it was about 2007, and it was a crossover between CRTs and flat monitors. So loads of people had these things gathering dust. So I used to go and pick them up for free, and I still got upset every time I burnt one of the transformers out, though.
Right, that was the golden era, to be honest.
Yeah.
In that time,
wasn't it?
Oh, on CRT boards, you had large inductors capable of handling several amps of current. You had huge flybacks that could easily deliver over 50 kV. You had power transistors capable of some of the fastest transition times that we currently have on the market. Horizontal deflection transistors, as Gerald will tell you, those are the gold standard when it comes down to speed.
Speaking of which, I got 4 TVs still. I have 2 32 inches and 2 28s, and I have to peel the horizontal deflection transistors out of them because I just blew my last one, and that one was 1600 volts.
Wow.
Oh, man. So you really ran out, eh?
Oh, yeah. Yeah, I'm at that stage now where I'm at my last 4 TVs, and I'm going to have to go digging. And I don't think there's too many left.
Even the 13009s, they're not capable of handling this voltage at all. And those are the common components on the market. You got to go to the now currently outdated and probably will never be produced in mass again, Toshiba transistors or National Semiconductors transistors, because their transition time is way, way faster than MOSFET. They are technically rated for operation at up to 12 megahertz.
I have a couple of those.
The reason for why you would need a 12 megahertz capable transistor, which is well within the radio transmission range for the ham bands, inside of a television, well, it's ironic because they didn't design it necessarily to be fast in that particular manner. They did design it to be extremely sensitive so that it would have a rapid transition, because in back EMF operation of a flyback transformer, what really produces the voltage is how fast you can shut off the field. So if you shut it off super fast, sort of like when Alexi presses that button and cuts the ultrasound, the rest of the electromotive force is released.
Absolutely.
Yep. Everything that it's doing on the inside now loops back around and hits it again. That's why it's amplifying everything.
Exactly. If you produce a change in the refractive index of space-time, the regauging factor tells us that it has to come back and reestablish equilibrium. So if you produce a change, it's going to come rushing back in as soon as the change is no longer occurring. So even if you have, say, you've increased your field from 0 Gauss to say 10,000 Gauss, but you've done that in a matter of a couple of nanoseconds, and then you hold it at 10,000 Gauss, what will happen is the refractive index will regauge, and you'll have this influx or back electromotive force wave that comes in from the vacuum conditions as they try to repolarize and match the currently electrically polarized conditions that you're producing with your device.
So basically it explodes out and then sucks back in.
Exactly. If you push pressure out, it's going to come back in. And pressure in atmosphere doesn't work anything like pressure in aether. We like to use the pressure analogies and the hydraulic analogies to describe the behavior of aether or the refractive index or the vacuum, whichever word you'd like to use. They all mean the same darn thing. If you push out, though, in the aether, unlike a fluid, it's not a finite quantity. It'll repolarize in order to completely nullify the extra magnetic fields that are produced, leaving you with a purely electric potential, which is why 2 electrons can be separated by a great distance and be stationary or not moving relative to each other and still have their electric charge, even as observed by one to the other.
So when I push that button, I'm multiplying that energy a lot, aren't I? Like it's a massive explosion, bigger than the amount of energy going in.
Yeah, you're creating an imbalance, and then because of the way that nature works, it's searching for that balance, and that inrush current is kind of what's smacking it, right?
Right, so you've got your ultrasonics running, you have a semi-stable state. The ultrasonics are keeping the ions trapped, but as soon as you let the ultrasonics go, the ions are no longer trapped, they can freely fly away, and when they do, they produce a magnetic field because they're moving relative to the environment and relative to the rest of the platform. And so in the production of that magnetic field, it's a virtual magnetic field because these are unbound charges. They're not trapped in a conductor, so that they can move right, left, forward, backwards, up, down, and they're not going to be constrained by exerting a force on the physical conductor that carries them because they are free charges. So unbound charges have a very different ability than bound charges. And
but that was the point of putting in the heat, though. So you're going to amplify the magnetism at 1 second, or
right,
less than a
brief
second.
For that brief moment, when you disconnect, you'll amplify your magnetic flux, and when it disconnects, you'll end up with nothing but your electric scalar potentials that are left over.
And that's why the back pressure in the Tesla coil was so important, because of the heat. When it shoots it back into a cold system, it immediately changes the field from a charge to a magnetic field in an instant.
Right. Think about the Tesla magnifying transmitter or Wardenclyffe tower. It uses a series of 3 coils. Now, the first 2 coils are the big ones that we need to pay attention to because they're the pumping coils. The outside coil, that's the primary. That puts energy into the secondary, which is on the inside, and is only about a 10-to-1 ratio. Now, it's the third coil that does the real work of conversion. The third coil takes the current and it converts it into pure potential because it's not magnetically coupled to the primary or the initial secondary. It's only being fed by a potential waveform. And so you can actually use shorting copper rings. I've got a few videos. I suppose I could show them and pull them up. But I did a really interesting experiment. I contacted Tesla in a strange way, which in my own mind, at least, it seems like I may have communicated with the man. I have no idea if it was that or just pure speculation on my part. But in any case, I ended up with a bunch of diagrams flowing through my head. And by the next day, I had built a very unusual magnifying transmitter, first kind that I had ever constructed like that. And instead of producing, and that will be it right there, instead of producing your normal bright white to bluish lightning bolts that you'd see flying out of the top load of a Tesla coil, this one was producing red sparks and a violet effluvia that was surrounding the red sparks. Now, to reach the red state, we have to actually get into singlet oxygen in the atmosphere. So that means the electric potential at the terminal would have to have been in excess of 1,000,000 volts, which technically it was. We had the transmission range to demonstrate that we had exceeded 1 megavolt, and the input power was still less than 2 kilowatts. The power supply was DC 20 kV, roughly thereabouts. And using a neon sign transformer and a set of rectifier diodes in a full wave rectifier configuration from microwave ohm transformers, we were able to produce a very type of unusual output that had a very large transmission range. The other interesting thing that was about this system, though, the thing that I've never heard anybody else talk about, is what we've termed plasma rectification. And so the effluvia, or the corona that surrounds the top terminal there, actually has a tendency to rectify the output and produce a net charge, which is capable of grabbing onto atmospheric ions and actually pulling them into the terminal. So you can look at the diagram we're seeing on screen right now and consider that to be equivalent to a radio tube triode. When the output potential is high and in the negative regime, we don't get, we do get mass ionic motion that pulls the ions in, and when it goes positive, the ions are held in stasis and they don't move in. So as the negative ions flow in during the positive side of the cycle of oscillation in this transmitter, extra power is added back into the circuit, which can be picked up by the primary coil, and that's your 4 or 5 turn coil at the very base. And during the other side of the regime, we have almost a complete stop in motion of all free-flowing charges. And so it turns on and off very much like a vacuum tube, just using the atmosphere as the rest of its enclosure. And we don't require high vacuum in order to produce this effect. I've tested it on the lab bench and injected ions from above using a small magnifying transmitter, and observed that I was able to feed power back into the primary DCPSU. And I was able to reduce the total current draw of that system by almost 10%. Which I know it's not a lot, but it's still significant enough to show that we could drain power from an external source, like, say, the ionosphere, if we could only establish a good solid connection with it. And this device had the potential required, according to Richard Feynman's diagrams and calculations that he had his students do in one class lecture, calculating out approximately, what was it, 700... it was either 700 megawatts and 400 megavolts, or it was 700 megavolts and 400 megawatts. I can't remember which order it was in. But anyways, there's a huge amount of power in the atmosphere. And the funny thing that happens is when we draw that power down from the atmosphere, it self-replenishes at a rate that's faster than what we can draw it, because we're surrounded by charged particles from the sun. And as soon as we create a gap by using them up and giving them a free flow path down to ground to neutralize the Earth potential, they just come rushing back in to repolarize and equalize that potential. So we could have terawatts of power floating around above our heads all the time.
Wow.
And we're doing nothing with it.
Goes to my theory with the pyramids, and that's exactly what they were for. Tesla figured it out years ago. But Tesla also figured out that there was a smaller version that could be given to each individual home, and they can run their own home off the same principle that wouldn't affect their neighbor. Not only would it not affect their neighbor, but it would increase their neighbor's output if they both had the same system. Kind of like two magnets getting close together and their fields interacting and magnifying the field altogether.
That's so cool. So hold on, this thing just, instead of like a lightning bolt coming down, you're actually getting the area that's closer, so you would get no lightning, you just get the effects, right?
Well, according to the original research reports, there were news articles written at the time of Tesla's investigations while he was actually operating Wardenclyffe Tower. So Tesla made a promise to Mr. Westinghouse, his original big investor. And he said to Westinghouse, if you provide me the necessary power that I need to run my magnifying transmitter at Wardenclyffe, I will put more power back into the grid system than it initially takes to start the system up. That was his promise. And with that promise, Westinghouse feeling very indebted to Mr. Tesla, who ripped up his what do they call it? He had a patent with Westinghouse. He was going to get a certain percentage of commission. That's what it was, commission. That's what I'm looking for. And so he ripped up his necessary commission because Westinghouse is about to go bankrupt. And by saving Westinghouse's company, removing his commission for the AC rotating electric field system, aka today's modern motors, Westinghouse felt so indebted to him that he provided Tesla with that necessary power to run Wardenclyffe Tower. And then actually what most people don't know is into Tesla's later years in life, they wonder how, without any kind of major career or not currently being employed with any large project, he was able to stay in the Hotel New Yorker and sustain the rest of his life up to the alleged reported age of 84 years. And so Westinghouse paid for all that. Not only did he pay for Tesla's research into his later years, he also paid for Tesla's investigation into his underground laboratories that actually ran between hotels and were built in underground tunnels. So a huge amount of money was dumped into it.
Yeah, it was in his notes. He actually used to travel between the Hotel New Yorker and his underground laboratory. And rumors are that he built a free energy generator as a backup generator for the Hotel New Yorker. But it's never been confirmed and it's never been found. But either way, Tesla was he was amazing in so many ways. There were a lot of things that most people didn't know. Like the Wardenclyffe Tower that he built was in, where was it, Ohio? Or am I getting that wrong? I'm not sure. But there was another one built in Canada, just in Toronto. Most people don't know about that. So he was doing experiments that people had no idea of when it comes to cross-border and how his electricity flowed. So I don't know, just amazing. Just to add to what you were saying, Jeremiah.
No, I completely agree. Underneath those tunnels that run between the hotels, there are a lot of mysteries in the walls, to say the least, and nobody knows exactly where they are. And because of restrictions, nobody's been able to take simple ground detecting radar or anything else down there and find exactly where there might be cavities or, other hidden areas that Tesla had covered in his time. So we don't really know, but perhaps someday somebody with just the right qualifications will go down there, get the right certifications, or completely ignore the laws and find these hidden gems that lie underneath the streets of New York.
If there's anyone out there that has the credentials, tell them to give me a call. I've had a dream. I know exactly where it is. If, of course, my dream is true. We'll see. Didn't mean to go dead air there.
Oh, sorry about that. No, I'm still.
No, I was just making a comment about a dream I had about a generator that was blocked behind a wall by Tesla's order, and it's something that nobody's ever seen before, and it runs itself, and I don't even know how much else, but it was one of Tesla's pieds de resistance, if you pardon my expression. And I don't think it got to the public or to the knowledge of anyone that was out there. So who knows? Like you said, maybe somebody with credentials or somebody who could slip down there and have a good look might find something like that.
I think, being honest, we have to admit that it's more likely to be somebody to slip down there. The idea of going through a credentialed system and actually getting certifications to go down there and properly investigate is going to be a huge public endeavor. But if somebody just happens to get down there and has enough equipment to peel away the wall and find...
Just like those guys tunneling into the wall over there in, what is it, Israel, onto the Great Wall thing they have there. They were tunneling in there trying to find the Ark of the Covenant or something, and they got caught. Yeah. Do one of those jobs, huh?
You guys remember that story from some years ago? Apparently, U.S. military was deployed somewhere in the Middle East, found a cave, went into the cave quite deep, met themselves up against a barrier that was causing harm to the soldiers, and
Of
apparently
pure
they
white,
managed. What's that?
of pure white diffused light. I've heard that story.
I can't remember exactly how they described it, but you'll probably remember more about it than I will. I didn't in the story that I read. It was very early on, so I didn't actually track the whole thing down and see how much value there was to it. But I do remember it being related quite to this. And so they went into this cave. There was some kind of energy barrier, almost like your modern invisible wall from Star Trek, or Teleforce type of wall. And so they managed to somehow disable this, went inside and found a almost 5.5 foot tall Vimana. Looked like a wedding cake, stacked in layers. I think it had, in this case, I think it was 5 layers, but don't quote me on that. Anyways, they found this layered structure, and it was some kind of a small craft that, in the end, the story says these soldiers tried to get this craft active or move it or get it out of the cave, and they all ended up disappearing. So take it with a bag of salt, but it
got in
does
the craft and left.
it does kind of remind me of some of these strange anomalous.
I heard something about that story. Apparently, yeah, the military have that area locked down and they concreted it over because they can't get it out. But like you, I don't know how much truth there is to that. It's just, I'm not even sure where I read that, honestly.
Okay, I have a couple of questions here. I've been showing some pictures and stuff in the background. I just kind of want to know what they are, if you don't mind. Like this one here. What's going on here?
Right. That.
Can you zoom into the more intricate structure there on the bottom left?
So like ball lightning or something?
I don't know if I know how, but let's see.
These were found.
Can you pinch to zoom on your mouse pad?
Yeah, it's not going back and forth.
No, he's in Facebook.
Oh.
Messenger.
Yeah, if he's on a desktop, he's not going to be able to do that. On a laptop, it's very easy to pinch to zoom.
Control 0. No. Control plus. Nope, that doesn't work either.
Anyways, yeah, so let's talk about what we're looking at. We know that for a while, Russia was allegedly generating a series of what looked like anti-gravitational or levitating spherical craft. The sphere is a pretty common shape that's reported, so it looks like this may be something related to that.
Yeah, these were found in Troy. They were dug up in Troy in an archaeological dig in 1880, something like that. Can't remember exactly. But what I see, again, it's like a 3D representation of that Roman swastika mosaic, the one that we showed you earlier. But when you look at it, it's this as well. So if you imagine that the swastika is representative of a spinning core, and then those 3 axes, that's what I see. That's my interpretation of it. And these things are found a lot. So that little UFO painting, I think any UFO buffs will know, the guy in the star that you just had up, the little guy crouching in a star with a blue background, Nathan.
Gotcha. I'm on it. I was just trying to get that picture so I can zoom it in. Go ahead.
And you keep finding this 8-pointed star, which is what a Merkaba is, with a point in the middle or a circle. In fact, when they replaced underneath the Dome of the Rock in Jerusalem, there's a little cave, isn't there? And they replaced the carpets not long back, and you can find these pictures on the internet. 2017, I think they replaced the carpets. And when they pulled the carpets back, there was an 8-pointed star on the floor with this circle in the middle.
Yeah, that's why the carpets are there.
Yeah, that's what I thought. Exactly what I thought.
Wow. Now that's pretty cool.
Yeah, and then when you're talking about flight and these anomalies in this, I think this is in a monastery somewhere. It's an altarpiece, I think, that spaceship. It's above the crucifixion, isn't it? I think a reverse search on Google would find it. But whenever I see these shapes, it draws me in. You know, these 8-pointer stars or 4-pointer stars, because I sent one to you, Nathan, where it's a picture of, let me find it, I'll forward it back to you. It's the when you rotate in 3 dimensions, the Merkaba 33 degrees across the points, you're looking at a 6-pointed star, the Star of David, which I think's probably just coincidence, but it's interesting.
Kind of like part of the hidden secret of the Freemasons, 33 degrees. Maybe it has something to do with the secret of spin.
The windings on my machine are actually 33 windings of twin cat wire. That's what I use.
That's very interesting. That's amazing work. Thank you.
So there's actually 66, but it's 33 twin. Can
you explain that a little bit more with the significance of it?
Just to verify too, 66 windings. I'm assuming that means you're running them bifilar.
No, well, no, they're in series. They're joined. So
they're in series, but are they running one way? Your first 33 is running one way, and your second 33 is running the other.
Yeah. So as I wound it, I go clockwise, and then clockwise, and then start the third one clockwise. So they're all following, but they're in series.
Oh, okay.
There are only 3 different colors.
To answer the question, then yes, that's called a bifilar configuration.
It is bifilar, is it?
Yeah. When you take 2 wires and you wind them simultaneously, like a twisted pair from a network cable.
Yeah, like bifilar pancake coils.
Right, and then you connect the end of one wire to the beginning of the other in the same rotational direction. They call that a bifilar configuration.
Right.
Okay, so just so you know.
Which is one of the secrets to the Gerard Morin washing machine motor / the actual PMH that was used in the Coral Castle build by Ed Leeds Scallon. Something that you should look into later. It's actually kind of connected to this in a way, because if you're running a rotating wind and then a counter rotating wind, you're taking the 2 and you're mashing them together using a compression of those 2 fields. And I believe that's exactly what was going on with the PMH and Gerard Morin motor. Just saying.
And the Rodin coil. That's actually one of the secrets is what you said, putting it in series.
Yeah, and the Rodin coil has counter wind in it just by its very wraps in that.
Right, without the interference pattern.
Yeah.
Right, so technically the Rodin coil is like a 13-filer coil.
Yeah.
Or it can have variations on that number, but it's a large number. It's at least 8 turns or more. 8 individual wires or more simultaneously wrapped, and they are all put in series in the configuration that is suggested by Marco Rodin. Now that
there's actually there's a variation on Rodin's design that I'm actually using, which is 2 channels. So you put 2 separate channels in series, so they're lying on top of each other, but the 2 channels aren't connected.
Yeah, that's actually an ideal configuration, and you and G should definitely talk about that. So he can tell you about a 2-coiler split setup where each coil is effectively still bifilar, but
like you said, there's different fractals, different scales of the design that look different.
Right, and so in Rodin's design, you have an enormous amount of parasitic capacitance.
It's not ideal.
But that's
not the ideal geometry, but I know personally Jordan from Alchemical Science was speaking with Marco Rodin, and they came to the conclusion that the geometry is close, but it's not the perfect geometry yet.
Okay, well, let me explain it this way. Imagine that you could maximize the factor that you actually care about, the total inductance, to maximize the strength of the magnetic field. What if you could increase your inductance by a tremendous amount, but almost completely eliminate the parasitic self-capacitance?
That would be ideal. That would be absolutely ideal. But I'm still learning about the Rodin coil, so
this is where Gerald has something to say, because Gerald is winding a very different kind of coil than the Rodin.
Oh yeah, no, Gerald is. I consider I call him the Lord of the Ring.
And so in his configuration, what you're specifically looking at, which I don't know if you guys have gotten into it or done the explanation on star coil designs, but you have two conductors that are taking, in general, the total net vector force and magnetic flux path through the Lorentz transform is still going to act like that thing is a solenoid coil, like it's a round coil. You'll have a north in one part and a south in the other. And the great thing about a star coil is that you can change the geometry, is therefore changing the length of each conductive path. Each conductive path is a straight line, and it has a parallel conductor running next to it in a bipolar configuration, so that each straight line acts as a single inductor and induces a current into the second line.
It's interesting you say that it is able to produce both poles, because something that the researchers that I'm following in the footsteps of, Daniel and Erica Nunes, they said they weren't able to produce a north pole. But recently on stream, I was messing with the frequencies and power level, and I actually was able to produce a north pole, but it wasn't stable. Like it wasn't even between the north and the south oscillation, if that makes any sense. It was
at this point, we
south,
can
south, 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 and a north.
Like, I don't know if you've seen the earlier part of the show. I've been using oscilloscope magnetometers and a variety of other equipment to measure these fields in real time. It's so much better than a compass or using a cell phone to try and take measurements.
Yeah, I plan on getting an oscilloscope soon. That's really a necessary part of the next phase, honestly.
Yeah, you don't necessarily have to have an expensive one. The probe is going to be the key here when measuring magnetic fields. You want a probe that has an extremely fast sensor. You could use a tri-field rectified coil arrangement to produce some kind of a sensor that you could simply rotate and get the perfect field geometry for maximum gain. Of course, there'd be almost no way to calibrate the damn thing, but you would be able to see your signal on the scope and tell whether or not it was higher or lower than some other part of the experiment. So at least you would get some comparative analysis.
We do appear to be getting the maximum efficiency of 155%, which is, I think, is pretty decent start for the coil. But it's not as efficient as the researchers that I'm following have.
Now, when you say 155%, do you mean 155% efficiency, as in a 1.55 COP?
So yes, so it's getting it's doubling the voltage while maintaining and slightly increasing the current.
Do you have any pictures of this?
I've got videos on my YouTube channel. We've done experiments live on stream. I got I had old multimeters, and then I got new ones, brand new ones that are specifically designed for the frequency ranges I'm using, just to make sure, and I put an output and an input circuit that was the same exact components, with the same exact energy going into both, but they're not connected. I'm using a stereo amp receiver so I can control the power evenly. It's a very basic setup, but if you go on beneficence.tv or YouTube/beneficence.tv, you can see how I did it with I think the video is called 155% efficiency with the rodent coil.
Yeah, I'm just curious how you do your math, because when it comes to COP,
well, like I've explained,
if it's right.
The numbers could be slightly off, just because multimeters, they're not exactly, some of them aren't exactly 100% accurate, but apparently this one has been calibrated. So and
your frequency ranges though too, and that's a huge part of the thing. Like, okay, so
you don't see the input circuit in this video though, so but I do have an input circuit, and it's not connected to the coil. It's the coil's in channel A output of the stereo, and then the reference circuit that's not connected to the coil is in channel B of the stereo receiver. So we got the same amount of power. I even tested it. Same exact amount of power going into both circuits, only the one with the coil is getting more power. And you can see when it's in its frequency range, the multimeter doubles the voltage while maintaining the current, but with outside of that frequency range, it's less on the output, like it's usually is. So it's really interesting. That right there is me demonstrating no pole, where that you do have a magnetic field. There's also a clip in here where I demonstrate the monopole. And recently I did find the North Pole. It's in there. It's probably very, very tightly packed, though. But yes, I have a do-it-yourself guide. So if you're interested in, if anybody's interested in how I did this and want to try to replicate it, if they have the ability to do so safely, definitely check out the description that has the link to the guide in there.
I like your work, Ben. I think that Roden was wrong in a lot of different ways, but I like your work and what you've done.
I appreciate that.
Yeah,
no, I'm not saying Roden was completely right, and I'm not saying that I believe him entirely, but I'm following in the footsteps of really the Nunezes and what they claim to have achieved. And so far, everything that my research has led me to is concluded that they were telling the truth, and it's remarkable. Just go on Breakthrough Energy Movements. I think it's 2017. Conference where Daniel and Erica Nunes speak. They have some remarkable things in that presentation that they give.
Oh yeah, I've seen almost everything Daniel Nunes put out before it was stripped off the internet. In fact, I still have in my
I'm so jealous.
a whole bunch.
I never got to see all that. I discovered them after their stuff got erased from YouTube, so I had to kind of piece together this. I had to kind of reverse engineer what they were doing.
I've been around since they started watching Roden and their first meeting with Roden, and when they started the PoE and the whole 9 yards. I was in the whole beginning of the internet or the YouTube explosion in 2008 when Thomas Bearden was just kind of putting out some stuff. Bedini was putting out a lot of stuff, and people were getting involved, like Mike Powers, and lots of people were building all these coils and getting involved in this.
There was a huge like not that long ago, like 10 years ago, people were building these, and then like a lot of people just stopped.
Well, I think my issue with Roden is anytime there's a geometrical coil, his name is slapped on it, and that's just not true at all. He makes very specific coils wound very specific ways. The geometry is completely different than, I'd have to say, 80 to 90% of the stuff that's out there. And I'm not faulting.
Real quick, I just wanted to add an addendum here, which is in the description, which people can't see if they're watching the video. I am still learning this, and this is the first time I've actually built anything like this. So I got the waveform wrong. I was reading it as a sawtooth. It was actually square wave. So, and I did update the do-it-yourself guide to reflect that and add a comment on there. But it on the video it says sawtooth. Just ignore that. It's square.
Please don't get me wrong, Ben. I love your work. Like I said, I ain't dissing on you at all. I think.
No. I think that is a large compliment considering what you've accomplished. So. I'm just a newbie in all this. I didn't honestly think I'd be able to get it to work. And when I did, you can ask my girlfriend, I woke her up. I was like, I screamed. I was like, woohoo! It was one of those moments where I was just like, what? What is going on? Is this doing what I think it's doing? It's pretty. Yeah, it's pretty incredible. So, that's like a rush. It's an adrenaline rush, and I kind of want to do it again. So let's build more. I want to see more people building these coils. They're not that difficult.
Well, I've built, like I said, 175 different geometrical coils. And
yeah, I want to get into some of the different coils that you built because I want to try to replicate some of the different ones.
Well, I was just about to say, I'm sorry, what is it? Magnetic. I apologize. I don't know your name. I'm just getting into your work. So, but the imposed Merkaba, I think I've never seen a coil like that before. And that I think has something different going on than what Ben's got going on, which is different than what I got going on. But they're all basically they're all in the same principle, I think. And they're
all on the precipice of fringe science. I mean, you see all these distractions on the news with SpaceX and Tesla, and like that's all distractions. This is where the real science is. This is where the real industrial revolution is going to be happening. These areas.
I think what I'm trying to say is one of the key factors, or two of the key factors in all three of these systems are spin and compression, right? Whether it's charge density or time compression, call it whatever you will. Refractive index, I'm not sure. Like I said, I'm still working on the theory when it comes to my system and everything else that's out there. But these three systems seem to have these three things in common, and they all do different. They have different qualities, but they all kind of do the same thing. So it's just interesting to me. That's all I'm saying.
Mm-hmm. If you've seen the documentary, I've been planning on streaming this, and I can't do it on YouTube, so I'll do it on my Twitch channel. I can stream documentaries and movies and stuff. If you've seen The Lost Century and How to Reclaim It by Dr. Stephen Greer, and I know what you'll say, he's very controversial in some areas, but regarding free energy, his research in that area is spot on. And this I highly recommend this documentary for anybody interested in free energy devices and the history of its suppression specifically. And they talk about the three areas of promise for free energy devices, and that's plasma physics, torsion physics, and ball lightning, which is basically the same thing as plasma. So,
all right, guys, let's get a little bit back to some of the stuff here.
Oh, he was muted. Yep.
I was just going to say that the other thing they mentioned is the only way it's ever going to get out is open source.
Yes, exactly.
You do.
That's why I released the do-it-yourself guide immediately. That's why I open sourced everything immediately. I think it's key. It really is.
So real quick, I want to know what's going on here. I'm going to play the video. So just let me know what's going on in this.
Okay, this was one of the early simulations that I did in 3D Studio Max, where because I was just seeing three coils, I put the vortex in. They're all pointing the right way, these space warps, and release the particles. And all I would get was this broken bike wheel, as I used to refer to it. And when it comes around, you see a bit of a figure of eight. And then somebody put me right if I'm wrong, but I heard somewhere that if electricity gets to one end of a wire and it can't get out, it goes back the other way. So therefore, in my mind, it was creating a counter-rotating field, which is where I did the other simulation and released the particles with six vortex, both two on each axis, going in opposite directions, and that creates the Merkaba out of the balls, out of the particles that I've released just in a 3D simulation using physics simulation. And it was just for me, because I'm not a scientist, but what I did notice in the core of it, there are particles that can't get in the middle. I don't understand it, but it makes sense because that's where I fix the ball, the magnetic sphere. And that, that's where it spins. So is there some kind of compression going on there? I don't know.
Is that Mercury?
Sorry, no, that's just particles released in a 3D environment in 3D Studio Max. And there's vortex space warps, and there's two of them in counter-rotating fields on each axis. That's my later experiment, and that's all they are. And when you release the particles, the odd thing is, because they're built, those vortexes are representing my wires on my machine, you see. And
so that open space that you're seeing, I know this isn't the scientific term of it, but I have that in the center of my coil. I call that the null zone. Right in that spot, there's no magnetic field, there's no electrostatics, there's nothing. It's null. That's why I call it that, but I know that's not the scientific term for it. But yeah, I would think it's a result of compression.
Yeah, but I was just overwhelmed by the fact it was creating the shape of the Merkaba, which again, you know, you've got to think a little bit deeper about it, haven't you? When
Yeah,
you see
that's an
these
amazing
things.
simulation. That's awesome.
Yeah, that's really cool.
But it's just finding people to talk to who can think a bit all over the place and sort of put your head straight. Because when you're experimenting on your own and you know, you start to doubt yourself and wonder if you're just imagining things, but you're not.
When you
I
think
understand completely.
when you think outside the box, you got to make sure you're not in an echo chamber. You're absolutely right.
Yeah.
Yeah, absolutely. Now, one of the things I learned as a calibration technician for 8.5 years in the industry is all about the kinds of crazy errors and mistakes that are easily made when taking measurements. Equipment errors, user errors, stray electronic fields, other contributing factors that one wouldn't even think about, like temperature compensation for certain conductors. You know, when I was initially training to be a calibration technician, we had an assessor in who ended up later buying the company, and this assessor, he asked me a series of questions, you know, to verify that I knew what I was doing as a Caltech. And one of the things that he did, which was particularly interesting, is, you know, he had 2 leads shorted at the end, red lead, black lead, just to 1 meter wires, connected to the input of a high precision Fluke digital multimeter with 6 digits of resolution. And he had it set to the lowest range. So what he did is he hit null on the leads. He took out the positive lead. He held it in his fingers for about 10 seconds, plugged it back in, and the meter showed about 350 millivolts. And so he instantly asked me, why is that voltage there? Explain what's going on. And so we had a long discussion about electromotive force, about triboelectrics, about thermodynamics, and a variety of other factors. And, you know, so without getting into the story all too deeply, it was funny to see that you can just simply hold a test lead, heat it up by a couple of degrees, and it'll generate a voltage, just like a thermocouple junction. And it's just something that's kind of overlooked, but measurement errors can come from anywhere. So the real thing is, you know, does the apparatus actually work? And so what you're doing, Merkaba Magnetricity, is physical experiments that don't need to answer that question in a less direct way. You actually have a physical apparatus, either works or it doesn't. I mean, that magnet ball, it could seize up or stop spinning, but if it spins and it gets going really quickly and it interacts with the mercury, then it's kind of like a, you know, black and white cut and dry situation. So
yeah,
experiment
is key.
Yeah, Jeremiah had to set me straight on a few of my meters that I was misreading.
At least we found the problems, right? Because
yeah, we did.
Like,
we did.
You didn't bring those problems to me and look at with 8.5 years of experience because you had no idea. Like, you could tell that there was an issue. You brought them to me because you knew there was a problem, and that just tells you right away. Like, if you've got a suspicion, you've got this sneaking feeling in your mind, like something is wrong with my measurement. Chances are there probably is. So take a deep look in your measurements, and sometimes that takes just as much as the experiment does in order of design and just backwards engineering how you took that measurement and what kind of contributing factors could be there. But if you work it all out and you're like, nothing could possibly explain why I'm still getting what appears to be a force, so, or a weight loss, or literally anything else, or an extraneous extra current. If you're dealing with double the voltage and you have the same current, I mean, that's as Benefactor was talking about, like, that's pretty much, you know, in that regime of over unity where we are seriously considering trying to do tests and experiments to verify and validate that, right? We would want to check phase angle. We would want to make sure that what we're looking at here isn't just an anomalous measurement error. So
exactly. And that's part of the reason why I built the reference circuit as visual confirmation, just to make sure, because I couldn't trust the multimeters. Like you said, I might need to consult with you to make sure, what I'm seeing is what I'm seeing,
Yeah, I'd be glad to tell you anything that you need to know about your measurement setup, and if you wanted to go on a private video and just show me what you've got connected,
yeah, like at a later point, that would be good.
All your meters.
Mm-hmm. For sure.
So, no, the whole thing is there's this problem. You have what's called effective power.
Mm-hmm.
Effective power is the best term that I've currently found, and I got it directly from Tektronix technicians that told me about precisely which series of oscilloscopes could measure effective power. So let me explain what that is. Effective power is the real point-to-point measurement. If you take a single cycle, let's say a 60 hertz AC sine wave, and you break it up into 10 million pieces, and you measure the current and the voltage at each point between those two pieces, and you generate a measure in watts. And so you stretch that out. So you got these 10 million pieces, and you measure every single one between the current and the potential. You have what's called effective power, because you've taken the thing, you've divided it into the finest scale. You have exact measurements. They're not averaged over time. They're not compensated like what a multimeter does. It averages. A multimeter will take, say, for example, 10 samples a second, or maybe 100 samples a second. Or if you're using a good fluke multimeter, 1,000, 10,000, even as much as 100,000 samples per second with a handheld multimeter. But that's with fluke, that's when you're talking RMS, that's when you're talking really high accuracies. But an oscilloscope is going to give you thousands of times more data, and one that can actually measure effective power will give you the true input-output